Hello YouTubers, Tada1295 here with another video, and this one is on a new little subject besides video games and whatnot. This is on science, physics and chemistry specifically. Maybe I'll be doing social sciences later on, but this is mostly physical sciences. Well, physics and chemistry. Maybe I'll be doing some biology later, some geology, stuff like that. I don't know if you guys are interested in videos like that. Comment on it. See what you want. Science videos. But anyways, I am interested myself in physics and chemistry. So the basic things of physics and chemistry, well, mostly chemistry, is atoms. But atoms have a lot to do with physics as well. Considering physics is the science of pretty much everything, and it has to do with matter, and atoms will basically make up matter, such as this crown, which I shall be using. Now, this crown is made up of atoms. The word atoms is made up of atoms. Everything is made out of atoms, and atoms is made up of matter. So, physics, you're studying matter, so you'd be studying atoms, too. So, before we take a look into the actual structure and stuff of the atom, I have a few words to say. This is going to be a series of videos about chemistry and physics. That's the only word I have to say. So sorry about that. I want to tell you some words that we will be using and that are important. Now these are more physics words. So, let me write. Okay, I'm back, and I've written down these 4 forces that are largely discussed within physics and will be having to do with here in chemistry, because really physics and chemistry work with each other in many ways. So these are, of course, the weak force and the strong force, which have to do with the atom itself, but I will not be covering these two in this video. I will be covering these two in a separate video, and I hope you guys can read this. Then there's electromagnetism. As you can see, I wrote a question mark behind it because I'm not sure if the actual force is called electromagnetism. I believe that's what it's called. I'm not exactly sure on my vocabulary of that. Please correct me in the comments if I am wrong. I'm sorry if I am wrong, but the one I do know is gravity. And that really has a lot to do with mostly the physics of atoms, which we really won't be covering that much in this video. But electromagnetism, we will be covering in this video. And electromagnetism is basically magnets, electricity, what's making this device run, what's making it light in here for me to do that, and what makes magnets on your refrigerator cling so that your mama can be proud of your A's. So, I have here a model of the atom that I drew myself out of calorie crowns. It's not the best, however. But anyways, to give you a little bit of perspective, there are 2 main parts of the atom, kind of. The nucleus, which is in the center of the atom, and this outer area, which has all the rings, which I believe are called orbitals. I get confused on that. The nucleus is made of these little subatomic particles called neutrons and protons. I'm not sure if I'm pointing out the right ones, but these are all made of neutrons and protons. Now this, of course, isn't going to be exactly right. I have no idea what atom this would make. I just randomly made this. And then the outside bit is a bunch of rings, I believe are called orbitals again, which each orbital holds a maximum of 2 electrons, which electron has the same electricity, electromagnetism. That's a little hint there. But up here, we have a key color-coded to the atom, but you can't really see that well. This one's really written really lightly, but that says protons. And protons are positively charged. Neutrons are neutrally charged, and electrons are negatively charged. So let's take a look at this. Help you understand this. So in the nucleus, we have positive and neutral charged atoms. So the neutral charge is really not going to do anything to the charges of the other two atoms. But the protons are positively charged, meaning that the nucleus itself is a positively charged area. By the way, these are all subatomic particles. And then these rings, these orbitals, which hold 2 electrons each, are negatively charged. Now, in electromagnetism, opposites attract, and positive and negative are opposites. So that's how that works. Positive and negative, and that's how bonding and chemical reactions and that stuff works. It works with this. It works with this. That this is negative and this is positive and that's neutral. That's how all that works. What keeps this together, I believe, is a small and weak force. But I'll be covering more about that in another video. I have to do more research on that. So, let me draw up another model of an atom, a realistic atom, a very simple one, helium, which is on the periodic table. Maybe we'll be taking a look at the periodic table today. Who knows? Okay, and I'm back. And I drew the atom of helium. Back up. That does say helium. It kind of went messed up on me. But anyways, that's what the atom of helium would look like. So, to point out what we got going on over here, we have one orbital, and each orbital has 2 electrons, so one orbital, 2 electrons. This atom is stable. It's not going to blow up. And it has 1, 2 protons and 1, 2 neutrons. 2, it adds up. It's positive. I mean, it's neutral, so it's all good. Atoms always want to be stable. To be stable, they have to be neutral. That's why atoms bond and stuff. But helium is a noble gas. And all the noble gases are stable because they have complete valence electrons in their orbitals. It's very nice. So, when drawing an atom, or whatever, to get the number of neutrons, you have to look at its atomic mass. The atomic mass of helium is 4, well, rounded to 4, it's like 4.12 or something. So, and there's 2, we know that there's 2 protons, there must be 2 neutrons. Now, there are different isotopes of helium, and we won't be going over isotopes too very large in this video, but that just means there's a variation in neutrons. Not electrons or protons, because that'd make a different atom, but neutrons. So that makes different isotopes of it. Some isotopes are rare, some are not. Such as the rarest ring, pretty much, that you could make, wedding band, that would not kill you, would be an isotope of platinum, I believe. Very expensive. A little something there. Now this is very simple, and it is a noble gas, and it only has 2 valence electrons. Most will have 8. The helium is kind of an oddball. To show you what's not an oddball, I also drew, painstakingly, neon. Now, neon wasn't that bad to draw as I thought it was, but there's a little bit of comparison of neon to helium. So, a neon's nucleus, this is a very beautiful nucleus, it is an atomic mass of 20 on this basic isotope. So it has 10, and it's oh my gosh, brain fart. But it has 10, its atomic number is 10. And its atomic number, such as this atomic number is 2, tells you how many protons and how many electrons are in there. Because those must match up. Protons to electrons must match up. The ratio must be the same, or else there's something wrong. It's not. It is something very wrong. Very, very wrong. So as it does match up around here. Anyways, so 10 neutrons, 10 protons. That's what that makes. And then there are actually 5 different orbitals here. Each orbital carries 2 electrons. Now, each electron is negatively charged, so they're going to repel each other. And I kind of messed up on this. All these orbitals should be farther out, but I didn't have the room to draw it. So these might not be happening. These might be alright, but that's a little close. They'd be like right there. So this one would probably be way up over here in helium, and helium would be thrown off into the atmosphere pressure somewhere and bash into some other molecule and blow up. But so yeah, that's basically atoms. I hope I covered everything. If you have any more questions about atoms, I'll be happy to do another video. I love doing these science videos. I love science. I'll be covering atoms in even more detail and whatnot, and doing even more videos on chemistry, such as the periodic table and whatnot, later on. So subscribe to my channel, like, comment. I want to hear your comments. And check out my other videos. I have some Minecraft stuff coming out. I have a bunch of new stuff planned for this weekend. If you're wondering, small stuff like my Tetris videos that I don't have to work very hard on, those will be coming out more all week when I have time to do them. And then my bigger videos, such as my Minecraft and RuneScape videos, that I have to do more work on, those will usually be coming out on my weekends. I will try to get videos out every week. No guarantees, because I don't know my schedule. So, have a nice day, YouTube. And I hope you learned something from my video.